Okay, welcome to this NEP, which is Notes, Examples and Practice Questions on Probability. So the title is Probability. So if you're writing these in your notes book or in a folder or somewhere like that, if you could write that as the title, and then we are going to have some brief notes. Okay, so starting with a subheading, this is our third and final lesson on probability, and the subheading is Theoretical and Experimental Probability. So theoretical probability is what you expect will happen in an experiment. So it's the theory behind it, it's the what we think the outcomes are going to be. Experimental probability is what happens when you actually do it. So when you actually do the experiments, that is going to give you another set of data. Now, in our blue box here, we have a little key piece of information which says, as you do more experiments, you should get closer to theoretical probability. So if you roll a dice 10 times, your results might not be scientifically accurate, whereas if you do it 1,000 times, so the more experiments you do, you should get closer to the theoretical probability. Okay, now we're going to look at some examples. So next thing you want to write in your book is examples, and we're going to start with example number 1, which is this one here. So it says, a fair dice is rolled 120 times. How many times would you expect to roll a 5? So expect means this is theoretical. So this is before we have conducted the experiment, what we think is going to happen. Now, we have 120 times in total, but what we need to do is we need to think about the probability of rolling a 5. So remember, probability is the favourable out of the total outcomes. So the favourable is there's 1 5 out of 6 outcomes. Now, to find the theoretical probability, we do the fraction of, which means times, the number of experiments. So that gives us an answer of 20 times. So we should expect to get a 5 20 times. Okay, moving on to question 2. The probability of spinning a 7 on a spinner is 0.22. If the spinner is spun 250 times, how many times would you expect to get a 7? So again, we've got that keyword expect. Expect is theoretical probability. So what's the theory? What's the science? Theoretical. Now, the probability of spinning a 7 is 0.22. So we have a 0.22 chance of the total outcomes. So again, we multiply it, and we're going to write that down in our summary later. So that gives us 55 times. Question 3. A spinner is spun 150 times and the results are shown in the table. So we've got our spinner here. So we get a 1 25 times, a 2 75 times, and a 3 55 times. And the question you need to write down is, do you think the spinner is fair? Justify your answer. So we need a reason as well as our answer. So do you think the spinner is fair? No, the spinner is not fair, because there are significantly more 2s than 1s. So that suggests that the spinner is not fair. Okay, it probably doesn't look like this. And we've done it a lot of times, so it should be fairly reliable, because remember this box. As you do more experiments, you should get closer to the theoretical probability. And then question B says, what fraction of the spinner do you think is the 2 section? Now, the 2 section gave us 75 out of 150 times that we spun it, so that's a half. So we would expect half of the spinner to be the 2 sections, so it probably looks more like this. And then we've got 50 and 25, so it probably looks something like that. So it's not fair. Okay, summary. So for expected outcomes, we do the probability times by the number of trials or the number of experiments. Okay, so that's what we did up here. We did the probability times by the probability times by. So probability times by trials. And then we're just going to write a little bit about the outcome. So a spinner is fair. A spinner or a dice is fair if there are similar, not necessarily the same, so if there are similar outcomes for each test. And then we are going to put that in our red box here. So we've got the summary. They are the key things which you might need to come back to in the practice questions. Okay, here are the practice questions. So remember, do these on a piece of paper or in your workbooks, not in your notebooks, because we just want to practice whether we can do these. See if you can do them on your own. If you're not sure, then you can come back here, watch the video, re-watch the notes, or ask for help. Okay, so question A says, here is a table showing the favourite colours of 100 Year 10 pupils. And then it says complete the probability row. So there are 100 pupils. The blue section is 52 out of 100. So that is 0.52. The red is 24 out of 100, so 0.24. The green, let's go to that, is 12 out of 100, 0.12. And the yellow, we don't know how many yellows there are, but the yellow is everybody who's left. So if we take away all of these, we get what's left. So what's left is 12. So there are 12 people that like yellow, so that's going to be 0.12 as well. Okay, part 2. The experiment is conducted across the whole school of 550 pupils. How many pupils would you expect to pick blue as their favourite colour? So expect, remember, expect theoretical probability means the probability of blue times by the trials. So blue is, probability is here, so 0.52 times by the total trials. And the total trials here is the total number of pupils, so 550. And the answer to that is 286 pupils. Okay, here, finally, here are the results for all 550 pupils. Was Year 10 a representative sample? Justify your answer. You can use the probability row to help. So we are comparing Year 10 and the whole school. So what I'm going to do is I'm going to calculate the probabilities for the whole school. So this is 275 over 550. So that's 0.5. This one is 0.28, 0.20, and 0.02. Okay, so was Year 10 a representative sample? So Year 10 says that's the probability and that's the probability, so that's about right. Blue's about right. Red's fairly close, so I'd say that's about right. But yellow and green. So yellow is very different and green is very, very different. So what I would say is year 10 is not representative because the probability of green and probability of yellow is very different to the whole school. Okay, very good, well done.